What's going on, guys? Welcome back to this video. Today we're going to talk about the marketplace. The marketplace is a machine that is running an e-commerce website which runs on or inside a Docker container. So again, we are conducting a penetration test on a Docker container. So basically, what's going on, guys? Welcome back to this video. Today we're going to talk about the marketplace. The marketplace is a machine that's running an e-commerce website. The e-commerce site runs inside a Docker container. So basically there is a Docker container on a machine. This Docker container runs a website. The website runs as e-commerce, right? So definitely there is a database installed on the Docker container so that the website runs smoothly and seamlessly. So basically this is kind of different scenario than the ones we have discovered in the previous videos. In the previous videos we discussed Docker container penetration testing, but we haven't discussed a case where the container is kind of complex, advanced more than the other containers. Other containers were running a static site. Here we're running a site alongside our MySQL database. So the process is not different. We're going to assume that we are conducting a penetration test for any website. I mean, could be like 20% or 30% of the websites are run by Docker containers. It's not that different. The process will become obvious how it's different when we get access or when we have a shell. We realize, oh, we are inside a Docker container. We are not inside a regular bash shell for a username or a user on the system. So let's get started. So there are three flags here we have to fetch from the site. Alright, so let's get started. The first thing we do all the time is the nmap scan. Let's log in. Alright, so here nmap scan shows that we have 3 open ports. Okay, now as you can see here we have 23 for SSH, 80 for HTTP, and we have 32,768 for a web server running Node.js. Okay, and there is, as you can see, we have some directories that have been discovered during the nmap scan, some of which /admin. Okay, and as you can see, /admin has been discovered by visiting the robots.txt file. Okay, so if we take a look here at the site, this is the website. As you can see, we have different functionalities. We have the home, login, sign up, and we have the products. Of course, these are demo products. This is not a fully functional site. It's just a demo. So if you click on Dell laptop, for example, we will be taken to the product page. I assume that the machine is still working. Yeah, all right. Anyway, we have to restart the machine. So, but basically you don't need to take a look at the products. Okay, so we have the home, login, and sign up. Now the login page, let me restart the machine. I guess we will have to do some interaction with the machine. All right, so this is the login page. It says you're already logged in. Now what you have to do, you have to sign up, okay, create an account, and then log in. Once you're logged in, you will see this page. So we have home, new listing, messages, and logout. So when you click on a new listing, I'm waiting for the machine to start. When you click on a new listing, it will show you a message with a description that you can send to the administrator, so that the administrator kind of takes a look at your entry or the listing you're trying to enroll in the site, and then they approve. Okay, so the page gets sent to the administrator, and the administrator opens the page to review the request or the listing you have just filled. Okay, so let's see how this works. So if we put in the new IP, Okay, sign up. Now username can be anything, test and test. Submit query, and we are logged in now or signed up. Let's log in. So test and test. Alright, so new listing, test and test again, submit query. As you can see, this is the listing we have just entered. And we have two options: contacting the listing author and report listing to admins. If you click on that, report listing, it will give you a confirmation button. So click on the confirmation button, report, and it will get sent to the administrator. Now what does that mean? So let's go back. So go back to home. There is not much. As you can see, this is the listing. There is not that much to discover on the site. We have the entries. In real case, we assume that there are prices and similar products, similar entries, whatever. So if you go to messages, we have the messages you receive from the administrator. Not that much functionality to interact with. Only the functionality we have to consider interacting with or testing or fuzzing is this. So adding a new listing. So here the site, let's recall that the site is an e-commerce website that must be interacting with a MySQL database. So if you are pen testing a website running a database, your first objective might be to interact with the database and see if the database is vulnerable to some kind of injection. But here first we have to understand how to interact with these boxes. So these boxes are testing areas. Testing areas for multiple web application vulnerabilities. Okay. Now there are multiple testing areas when you pen test a website. You have the URL and you have the input boxes. There could be comments, search areas, any box that lets you send an input. So these are input boxes. Okay, so we have multiple candidates among the OWASPs to test. We have the cross-site scripting. So if we enter a sample payload here, let's select SSS and enter a sample payload. This is a reflected cross-site scripting. It means when we send the input, the browser will interact with the input and send the output back, as you can see here, to the screen. So submit an inquiry, and as you can see, we say the browser sends a pop-up with the phrase we sent in the payload. So this means that this site is vulnerable to reflected cross-site scripting. We say reflected because the browser reflects on the input and send the output back to us. So okay, don't show this. All right, go back to home, and we have a new listing. As you can see, the title is script alert hello. So the key takeaway here is that we have a site that is vulnerable to cross-site scripting. Now normally cross-site scripting the reflected one, there is no benefit of engaging the site with the cross-site scripting if you know that the user cannot interact or cannot visit the link. So what do I mean by that? It seems vague. If you don't know what's cross-site scripting, then you have to review it, because it's intuitive it's intuitive, guys, to know what is cross-site scripting. I mean, but a review on cross-site scripting is when you test for reflected cross-site scripting, we aim to build a URL that is sent to the user. When the user clicks on the URL, we aim to grab the cookie of that user and hijack the session. So it looks like here in the current scenario that there is no user that can visit or could visit the link that we can create here. But if we go back to one of these products like test, as you can see, we said earlier that there is a functionality titled report listing to admins, which means if we click on this one and report, as you can see, the message is saying that the admins will visit the request and get back to you. So we're assuming, since this is a CTF scenario, we're assuming that there is some command that visits the URL of the product we create, okay, like curl command or whatever, and this trigger a behavior much like similar to a behavior where a user visits the page that contains the XSS payload. So if you go back here, I create a new listing. So this time we aim to grab the admin cookie. The product here, or the listing, is sent to the admin. Okay, so the admin opens the page. We are sure of that based on the behavior of the products or the past products we have sent, or the past listing we have sent. So if we enter an XSS payload here that grabs the cookie, or a cookie stealer, we're supposed to receive the admin cookie after they review the listing for approval. So if you go back here and grab some cookie stealer, you can find these notes in the channel membership, guys. Subscribe to the third tier of the channel membership to be able to receive these notes. Some of these notes are online and other ones are PDF drives. And read the description, please read the description of the tier before subscribing. All right, so let's grab one of these. I chose this one. So what does this payload do? As you can see, it fetches the cookie using document.cookie, and it encodes the cookie with base64. So when we receive the cookie, it's going to be in base64 format. As you can see, this is the IP address of my machine, and this is the port I am running to listen on the incoming requests. So we go back here. So that's what I did. I'm going to clear because we are doing a new attempt on the machine. So Python -m HTTP server. That's the server that's listening on port 8000 now. So what's going to happen here? Let's go back. When we send this, okay, we will receive all incoming requests on port 8000. So let's send that. Submit. Okay, now when we submit this, as you can see, a request is sent to the server. And this is not the admin cookie. This is the user cookie, my user, the test one. Why? Because I haven't yet reported the listing to admin. I'm initiating the requests from the user that I am signed in with, the test user. So when I click report listing to admins, report, now the admin will visit the product page. And hopefully visiting the product page or the listing we have entered will trigger the reflected cross-site scripting payload, which will grab the admin cookie. Let's go back and check. So as you can see, we received 2 additional cookies that are different from the ones above here. So if we take one here and decode it to base64, or from base64 to plain text, that's what I did earlier, but let's do that from scratch. Echo and paste this, base64-d. That's the admin cookie token equal this. Let's take this one. All right, so what are we going to do with this? We're going to change the active session cookie with the new cookie here, so that hopefully this places us in the admin account. So this is the /admin page. If you remember the /admin page from the nmap scan. If you try visiting this page, it will send you, oh wait, the IP changed. You're gonna have to change this to /admin. As you can see, you're not authorized to visit this page. All right, if we inspect or use Firefox developer tools and we go to the where was this, the inspector, performance, the memory, I kind of forgot this. Okay, so this is the token. As you can see, this is the cookie of the user. If we replace this with the new value of the admins and refresh the page, and now as you can see, we got access to the admin area. Let's remove these, we don't need these, close one. Okay, we got access to the admin area, and the first thing we got is the flag. That's the first flag in this challenge. So wrap up for the first milestone. What we did is cross-site scripting on an e-commerce site. We tested the input boxes, which are regularly or usually the testing areas for web application vulnerabilities. We discovered that the site is vulnerable to cross-site scripting, and we discovered that there is a mechanism that makes us able to send the link of the new listing that contains the XSS payload to the admin. The admin visits the page that contains the XSS payload, and the payload is triggered. We receive the admin cookie and we hijack the session. So it's a combination of cross-site scripting and session hijacking. Two vulnerabilities, one of the most popular vulnerabilities in the OWASP top 10. So this is the flag and this is the admin area. All right, next. So as you can see, we have the list of users: system, Michael, Jake, and test. When you click on every user, we have the ability to delete the user, and we have the ID of the user is administrator, false, not administrator, true for administrator. Click on Michael, it is administrator. Jake is also administrator, I suppose. Yes, it is. Now notice what is changing when we, or while clicking on every single one of these users. The changes are seen in the URL. So the URL, as you can see, contains the parameter user, and the ID is changing, as you can see, according to the user we are visiting. So the user we are visiting is Jake. This is the ID, and as you can see, the user equals 3. Now, we said earlier, guys, that URLs are also testing areas for our application vulnerabilities. Of course, here we're not testing for IDOR or any other vulnerabilities. Here we are looking to interact with the database. So here there is a database, guys. E-commerce websites run on databases. So we want to somehow dump the entries of this database. So URLs can be, or the parameters found in the URLs can be vulnerable to SQL injection. So SQL injection can also be found in URLs, not only in login forms or search areas. URLs are also field places or playgrounds for SQL injections. So what we're going to do, we're going here to initiate a couple requests. So let's take a look at the first request. All right, so the first thing we want to, during pen testing a database, first we want to find out the number of columns. We do that by using union select, and here we assumed, it's kind of assumption. It could work or it couldn't work. We assume that there are 4 columns. So we used union select. These are the payloads. Let me show you the payloads. This is the first payload. Do we have some zoom in here? Yes, we have. That's the first payload. So we assigned a random user ID, and then we used union select 1, 2, 3, 4. This assumes that we have 4 columns. Now, how do we know if this is the correct assumption? It depends on the output. So if we send this request, okay, to the server and it didn't respond with an error, it means that the number of columns is 4. As you can see, I sent this request and I haven't received any error. It means that we have 4 columns. The next step is to find out the databases. So these are popular payloads, guys. You can find them in the internet, or you can use my notes to find these payloads. Let me check union select. Yeah, I have them here, as you can see, depending on the kind of testing. All right. So what we're going to do, we're going first to grab the name of the databases. So union select, the same payload here. We leave the first column. In the place of the second column, we use group concat to retrieve the schema name. Okay. Now the schema name is retrieved from the information schema, as you can see here. So we use the schema name we supplied with the second column. We can do it with the third column if you want, it doesn't matter. So if we run this payload on the website, we're supposed to retrieve the database names. We have marketplace and information schema. All right, after we retrieve database names, we need to retrieve the table names. Okay, so tables can be retrieved from information schema.tables. Okay. All right, so that's the payload. Again, in place of the second column, we use this payload group concat table name. You want to retrieve the table names. Okay, from which database? From the database that is marketplace. So when we run this, we retrieve the payloads, retrieve the tables from the database marketplace, we have these tables: items, messages, and users. So next step is to retrieve the columns contained in the table users. Why? I don't know why I get back. Why I always get back here. Let's go back to the notes. So the next payload is group concat. To retrieve the column names, we supply instead of table name, column name. Columns are retrieved from information schema.columns. The condition is the table name equal to users. Execute this and you retrieve these entries. So users table contains these columns: ID, is administrator, password, username. Our aim is to retrieve all of these entries. By retrieving the entries, all of them, we'll be able to retrieve the username, the password for all users. So what we're going to do, we're going to get back here and modify this. The payload will be group concat. Okay, we need to retrieve the ID, the username, password, and is administrator. And of course, we use \n to separate the entries with a line, and these are retrieved from the marketplace.users database name dot the table name. So when we execute this, guys, here, when we execute this, we're going to retrieve as you can see, the ID of the user, and this is the username, and whether it is administrator or not. If it is not an administrator, you will see the value 0. If it is administrator, you will see the value 1. It doesn't matter. Now we have these users. Now we have two paths. The first one is to take every single hash of these and crack it using Hashcat or John Draper, or the other intended path of this challenge is to check out the other table. The other table was messages. Using the same way or following the same methodology, we can retrieve the contents of the entries inside this table. So these are the columns. We are interested in seeing the message content. So using the same method, guys, we use it here. We see we have this message: hello, an automated system has detected your SSH password is weak and needs to be changed. You have been generated a new temporary password. Your new password is. This password belongs to one of these users: system, Michael, Jake, and test. You don't have to run some sort of brute force to find the correct user. Just test out the password with every single one of these users and you'll be able to log in as Jake. So here, as you can see, I used the password on Jake and I was able to get access to the user Jake. That's the first foothold, SQL injection. Alright, ID is Jake. I am placed in the home directory of Jake and I can retrieve the user flag. Alright, the next step is to conduct privilege escalation. So without resorting to automated tools, we can just save time and run some manual entries, manual commands like this one, sudo -l. We see what kind of privileges Jake is assigned. We want to see what are the commands that Jake can run as sudo or in privileged mode. So we discover that that Jake can run this backup script as Michael without the need to supply the password of the user Michael. So which means that Jake can run this command or this backup script as the user Michael. This is great if you want to conduct a horizontal privilege escalation, escalating from a low privilege user to a higher privilege user, not necessarily to be root. So Michael is seemingly has higher privileges than Jake. Alright, let's take a look at the contents of the script. So cat backup.sh, and here we see the contents of the script. So it is a bash script. It displays backing up files to the user upon running the script, and this is the command that dictates the behavior of the script. So tar cf /opt backup.tar, and we have an asterisk. Two things to take away from this command. The first thing is that the backup script here performs a backup on all the files, okay, that does exist in this directory. So it takes all the files in this directory and backs them up into a file named backup.tar. So when we untar the backup.tar file, we retrieve all the contents found in this directory. So if we display the contents of this directory, we can see we have backup.sh and backup.tar. So apparently the backup script here doesn't have much content to backup. Okay, it only backs up the script as for now. So that's the first key takeaway from this command. So here, this key takeaway tells you the behavior of the script. The other key takeaway here is that the use of asterisk with the command tar. Using asterisk with command tar comes with negative consequences. So there is a very prominent way to abuse this functionality in the tar command. So if we go to Linux privilege escalation and type tar, no, this is too much broad. Let's type checkpoint, exact checkpoint. Yeah. So we have two methods to exploit wildcards. Here I use this on cron jobs. It doesn't have to be on cron jobs. It can be, yeah, tar as an example, as you can see here. So we can run a revert shell using MSF Venom, or we can run netcat revert shell. Both methods can work. In this scenario, I use this method. So what I did, let's go back. The first thing we do is to create a shell. Okay. Now this shell will contain this line. This line is a netcat reverse shell that upon running the shell, it will connect to my machine on port 4545. And then here comes these lines that exploit the functionality of the wildcard, the checkpoints. Simply we are telling the tar command, in addition to backing up the files inside, it will execute the script. So beside backing up the files, tar can execute system commands using the checkpoint action. So we tell tar to execute shell.sh. Okay. So when backup.sh runs the script, it will, yes, come to this command. It will perform the backup, and along its way, it's going to, as you can see, execute the shell. Right. So next step now, after the shell is ready in the directory, we give the shell permission to run, because apparently it needs permissions to run. And then I use sudo -u run backup.sh as Michael. Remember that backup script is not running as a cron job. You have to execute it yourself. Now execute backup as Michael, but it didn't work. I realized I have to give permissions to the backup tar that's created, and then sudo -u, we execute the script, and once executed, I receive the shell here on port 4545. Now once here I jumped into another shell. Apparently here I performed horizontal privilege escalation. I moved laterally from Jake to Michael. Now Michael is part of the Docker group, which means here we discovered that we are inside a Docker container. Okay. Now when a user is part of the Docker group, it means they can enumerate and interact with the existing Dockers, which is something that's positive. So we list the images, and we have these images. Remember, when we talked about Docker containers, the aim is to select one of these containers and mount the complete file system of the host to that container we selected. So let's go here and use docker run. Alright, as you can see, we have two commands to perform this. So here we select the directory to which the complete file system will be mounted. --rm, it will delete the contents of the file system once we exit the Docker. -it to interact with the Docker by assigning a new shell, and then we change the root directory to the directory we chose earlier, which is, you know, mnt or mount. That's the command when applied practically. Docker run -v. Here we mount the complete file system to /mnt on the Docker, of course. --rm removes the container once we exit, -it to interact with the container when we run this command, the name of the container image, alpine, change the root from root to /mnt, and run shell. When I run this, I receive a new shell as root. Okay, we are inside the / directory and we see the complete file system. Now when we go to /root, we can see the root flag, and we are able to retrieve the flag of the root directory. So that's the complete walkthrough of this machine, guys. I hope you enjoyed the video, and I will see you later.